Hello once again. Welcome to JCL Tutorials, your best learning platform. I welcome you once again to watch this particular segment. Thanks for clicking to watch in the first place. I would also urge you to scroll down and click the subscription button so you can receive notifications on videos that I'll be producing concerning lessons that I prepare. These lessons have to do with governance, politics, lifestyle, culture, talking about current affairs, geography, history, and many more. Now, after doing that, you can go back to the previous videos I've made, and I believe a lot of people have enjoyed those videos. You can also share with other friends. Don't leave them out, and let's keep learning. All right, so my focus in today's video is going to be on the international DateLine. One of my viewers typed in the comment section and wanted me to discuss the international DateLine. So I came across the comments. I read on other platforms where a lot of learners or people were also expressing difficulties understanding this concept that has to do with the international DateLine. So the objectives are simple in this video. By the end of this video or lesson, you'll be able to describe the international DateLine, know its pathway, and know where it is drawn on the surface of the globe. Then you can also sketch and put that line on the surface of the globe. Apart from that, the new year is coming, and we are told that there are places on the surface of the earth that experience the new year before others. So in this video too, I'll take time to identify those zones or areas that are likely to experience the new year before others. Talking about 1st January and then 31st night and all the issues surrounding that particular discussion in terms of time zone or the calendar. So now let's get into it. Let's start with the meaning. What is the international DateLine or the idea? It can be abbreviated as idea. Okay, so we'll look at the meaning first. Now when you take the description or the meaning, you look at the ideal is a line. It's just a line. I even made a video concerning longitude and latitudes, and it's one of the longitudes because longitudes are drawn from the North Pole to the South Pole, and these lines are imaginary lines. So when you get to the ground or the physical ground or the actual ground, as far as mapping is concerned, you will not see these lines on the surface of the earth, but geographers put them on the surface of the earth. This one has a particular purpose. It might not look like the other longitude drawn from the North to the South Pole, but then it's basically for the time and the calendar. So you look at it, it said a line standing between the south and north poles. That is the boundary between one calendar day and the next day. So what day are you in, wherever you are watching from? The next day, this is what the line that separates or determines that tomorrow is going to be Tuesday, tomorrow is going to be Thursday, tomorrow is going to be Sunday, and today is Monday, and so on. When it was established, 1884, it passes through the mid-Pacific Ocean and roughly follows a 180 degrees longitude. I'll tell you how they got the 180 degrees longitude, north-south. So it's also a line drawn from the north to the south. I know my good social studies students who have been watching my videos probably might be connecting this 1884 to something else. Yeah, I know. Historically, it marks the year that the Berlin Conference was held, and you know about the Berlin Conference, so you can watch my political historical videos and then you see all the issues over there concerning the Berlin Conference. But that's not where our focus is. Our focus is on the international DateLine, that imaginary line that determines what day we are in and what day is tomorrow. So the calendar day is simple as that. So it is also known as the line of demarcation. Line of demarcation. Now let's see how it is drawn on the surface of the globe or the earth. So this is the globe, but spread on a flat surface. That's why we are seeing all the continents: Africa, Asia, North America, South America. We have Europe, and that is the line you are seeing over there with this color drawn. Why is this not straight as the prime meridian? We know the prime meridian, which is longitude 0 degrees, is also drawn from the North Pole to the South Pole. Why is it not straight? And this one looks zigzag. I'll tell you about that and why it is drawn this way. So you see it passing through the middle of the Pacific Ocean. So that's what we said in the previous video, the mid-Pacific Ocean. Alaska on this part. Then you see Tokyo, Japan, and these countries in Asia also on this part. So you can have this line separating the North Pacific Ocean. So you see the North Pacific Ocean, and there are some islands here. Then you see those Fiji Islands, Tonga Islands, Samoa, and Auckland. You see them, New Zealand. All these areas are a bit closer or are closer to the international DateLine. So that is what we see, and that's how it appears on the surface of the globe. Now, as it appears this way, let's see how it appears and how different it is from the prime meridian. So you see that one over there, it's the one showing the prime meridian, and that's longitude 0 degrees. Where is this one found and where is it located? We are going to be seeing that soon. When you turn the globe the other way, the line on the opposite side from the north to the south pole is this one. So you see directly opposite. So when you spin, you have the globe, the physical globe, and you spin it, you see the IDL on the other side. So this one is showing the prime meridian, which is longitude 0 degrees. And this is showing the international dateline, or the IDL, which is longitude 180 degrees. So that is how it appears. Now, the numbers or the degrees is just telling the distance between them. What is happening here is that when you spin, let's go back. When you spin the globe, this one, just say this is the normal one you are facing, and you spin it. If you get to the back, directly opposite, counting from, so they start the reading from 0 degrees. As they read, look at this. As the reading starts from here, 1 degree, 2, 3, 4, 5, 6, 7, 8, 9, 10. The moment they get to the halfway of the earth, you know, the earth is spherical, but then when you circumnavigate or you go around it, it's a 360 degrees direction or movement. Okay, so that is the angle. So that's why when you pick one area, so areas on the surface of the earth, the reason why they experience different time zones. So you see on your phone +1, -1, +2, -2. So you see UTC, coordinated universal time. That's what they use, and it came to replace the Greenwich Meridian time in the 1970s. So that is what we are using currently, the UTC. If you watch movies, if you watch series, you have current times displayed in UTC. So you see +14. Plus means that plus a certain number of hours. Minus means minus a certain number of hours. Okay, so what is happening here is that when you take two locations that are apart, or one is 1 hour ahead or behind, it's just a 15 degrees what? Distance or separation. Okay, so 0 to 15 degrees, it means that if a country or a city is on 15 degrees here, it means that that city will be 1 hour ahead or behind this particular area. Okay, so then it goes 30 degrees plus 2 hours, then you have 45 degrees plus 3 hours, then it goes like that. If you are reversing, then it is minus 45 degrees, minus 30 degrees, minus 15 degrees. That is how it's displayed. If you watch my video on longitude and latitude, you understand how these are calculated. So when we count from this side and get to that side of the globe, halfway, we get to 180 degrees, because half of 360 is 180 degrees. If you get back to the 0 degrees, it means you have covered 360 degrees. That is why when you divide the 360 degrees by the 15 degrees, which represents 1 hour, you are going to get 24 hours. So it means that the earth will use 24 hours to complete a rotation. You know that in science and in social studies. So that is how the whole thing works. So it is simple math and simple geography. All right. So that is why we have this one as longitude 0 degrees and this ideal as longitude 180 degrees. Now let's see something. So this is how it shows. So I was just telling you that directly opposite. So this line shows the prime meridian. You see the arrow, and the one behind it is showing the IDL, the international date line, on the other side. Now let me tell you quickly why it is not straight. You know that there are a lot of physical features that we call landmarks. If we draw this to be straight as the prime meridian, it is going to make time reading very inconvenient, in the sense that if you have a highland or a mountain or one island in Kimbati or Fiji or Samoa or Tonga, if that highland has the international date line passing through, it means that if it is straight, it's going to cut the highland or divide it, not as in splitting it, but then the line will touch the surface of the highland and divide it into two. which means that if I go there or travel to that particular highland with a friend, and the friend is on the other side, and I'm also on the other side, on top of the highland, because that line is straight, it means we are going to say this one is in Tuesday, or this one is experiencing Wednesday, or this one is experiencing a day ahead, and I am behind time. That will be very inconvenient. So at a point, the IDL will have to be drawn in that zigzag way to actually cover certain what highlands. So maybe if it is a mountain or a forest area or whatever, it could just capture it and then save us from what having that problem reading the calendar day or time. So that is why it looks zigzag. So it's to give space for landmarks to be what captured into a certain zone or location. So time reading will be easier and very convenient for us. That is why it is not straight as a prime meridian. I hope you get that. Now let's move on. Movement across the international date line is very, very simple and very easy. People can travel by sea. They can use the ship and the ship can cross. It's an imaginary line. It will not block you from crossing it. You can go with an aircraft. Now, when people move on the surface or across the international date line, what happens? This is what happens. So don't get confused. I know by drawing this or sketching it on a paper, you would have indicated that the Western Hemisphere is here, okay? And the Eastern Hemisphere is here. Now, you know why we are placing the Eastern Hemisphere here and the Western Hemisphere? Don't forget that the IDL is on the other side, directly opposite to the prime meridian. You get it now? So it means that if we turn or spin the globe, we can have the west here and we can have the east over here. You get it? But then now we are focusing on the IDL, which is directly opposite to the prime meridian. Prime meridian is on the other side. So it is fair to understand or say that the Eastern Hemisphere will fall on this side and then the Western Hemisphere will be on this side. Now, if a person travels and crosses the international date line into the West, the person will gain a day. It's happening. Let's see how it is displayed over here. So the 180 degrees IDL, you see what is happening. If a movement is made from the east to the west, you gain a day. That is across the international date line. And another movement is made vice versa, or from west to the east, you lose a day. So look at these locations. Now we see map of South America here. America is somewhere here. So Alaska is here. So the mid-Pacific Ocean, the IDL passes through, crosses. Then you see these islands in these areas. So Tokyo in Japan. So coming back to this, the first cities to experience a new day or that are likely to experience a new day, Auckland. So you can see Kiribati. So Kiribati on that part where the IDL passes through. So Kiribati will be experiencing the new year first. You have New Zealand, areas around New Zealand. And coming back to the top here, Alaska and all these places are likely to experience the new year first. And even Wellington. From the top here, yes, you have the areas around Russia, Commander Islands. So the idea is actually separating the Commander Islands and the Attu Islands in that area of North America. So I believe you got that part. So quickly, let me leave you with an exercise. So you look at this illustration here and the diagram here. There are some boxes where this has been labeled as 180 degrees, 0 degrees, which labeling indicates the equator, prime meridian, and the IDL in the diagram above. I think you can get these ones. What should be in this box that has the 0 degrees, which is the prime meridian, and we know this is the IDL, and this is the equator. The equator divides the Earth into two equal parts, northern hemisphere and southern hemisphere. Now, describe this on paper. You can post it in the comment section. What is the path, or describe the path of the international date line for just 4 marks. And I know you can do that. With the understanding you've gotten from this video, I'm sure you are settled and all your difficulties are being cleared now with regard to the international date DateLine. I'll be coming your way again with other interesting lessons. If there's any question you would want to ask or any submission, you can put it in the comment section. I welcome all of them, and then please don't forget to share this video, click the like button, and put a comment there. Even if you don't have a question, put a comment in the section for me, and I would appreciate that. Thank you for watching JCL Tutorials. Have a good time in this season and enjoy your moments out there. Take care and be safe. Bye.